Hey guys, today we are going to continue learning about the Pythagorean Theorem, and today we're going to actually talk about Pythagorean triples. A Pythagorean triple is a set of positive integers, a, b, and c, that fit the rule a squared plus b squared equals c squared. Now when I say integers, it's important to remember that integers are numbers with no decimals, no fractions. So we're talking about positive numbers, natural numbers, numbers we count with. Okay, so no decimals, no fractions, just positive integers. So 3, 4, 5, that is the most common Pythagorean triple, and it's a Pythagorean triple because 3 squared plus 4 squared is equal to 5 squared. So that's 9 plus 16, which is 25, and 5 squared is 25. Okay, some other common Pythagorean triples are 5, 12, 13. 5 squared plus 12 squared is 13 squared. 8, 15, and 17, and then 7, 24, and 25. And any multiples of these bold triples are Pythagorean triples as well. So if I double this 3, 4, 5, I get 6, 8, 10. 6 squared plus 8 squared is 100. 10 squared is 100. I can triple this 3, 4, 5 and get 9, 12, 15. I can multiply 3, 4, 5 by 10 or by anything, and I will get another Pythagorean triple. Same with 5, 12, 13. If I multiply them all by 2, I get 10, 24, 26. I can multiply them all by 3 or by 10 or by any number I want to. As long as I multiply all 3 by the same number, I get a new Pythagorean triple. So we are going to use a Pythagorean triple to find the length of the hypotenuse of this triangle. So 24, 45, and the hypotenuse. 24, 45 is right here. 24, 45, 51. X is 51. It is a multiple of the 8, 15, 17 triangle. Okay, so we'll do that again. We'll find this hypotenuse, and we can probably do this one without looking at the chart. 30, 40, 50. That's a 3, 4, 5 triangle multiplied by 10. 30, 40, 50. X is 50. Okay, there are some good uses for Pythagorean triples, which we will talk about in our next lesson. Okay, now let's go back. I skipped a couple problems in these notes, and we're going to go back and do those now. So first, find the area of an isosceles triangle with side lengths of 16, 17, and 17 meters. So that would look like this. Okay, so there's an isosceles triangle, 2 17-meter sides and a 16-meter side. We will find the area. So the first thing I need to do is draw in the height of the triangle. Okay, so there's our height. Now I can use the Pythagorean theorem to find that height. This is a leg of a right triangle right here. A leg of h, a leg of 8. Half of this 16. And a hypotenuse of 17. So I can do h squared plus 8 squared equals 17 squared. Okay, so let's do minus 8 squared on both sides. So I have 17 squared minus 8 squared. And that is 225. So h squared is 225. And we'll take the square root of both sides. So the square root of 225 is 15. So the height of this triangle is 15. Okay, now the area of a triangle is 1/2 times the base, which is 16, times the height, which is 15. Okay, so that's half, or 0.5 times 16 times 15 is 120, and this is in meters, so it's 120 meters squared. Okay, one more of those. This time the picture is drawn for us. We've got an isosceles triangle with legs of 50 and a base of 28, and I need to find this height. So I've got a 14 right here, that's half the base. So I have h squared plus 14 squared equals 50 squared. So we will subtract 14 squared from both sides. H squared equals 50 squared minus 14 squared is 2,304. Now let's see if that is a square number. Square root of 2,304 is 48. So I do the square root of both sides, and I find that the height of this triangle is 48. So the area of the triangle is 1/2 times the base, which is 28, times the height, which is 48. So 1/2 times 28 times 48 is 672. So the area is 672, and this is in feet. So it's 672 feet squared.